Welcome back. Today we are going to be using the Arduino software to program the BrainPad. If you have watched the previous episodes, you know that I have been trying to get the BrainPad working with multiple platforms. We have done Mbed, we have done MicroPython, and TinyCLR OS runs on there. That is the default option. And today I want to show you how to use the Arduino on the BrainPad. Now this one was put aside because I've tried a couple times and I couldn't get it to work. But shout out to Roger Clark, who have been a great help. This guy is like an open source superhero, and he's extremely helpful. I even offered him a beer and he said, no, it's okay. So thank you very much, Roger, for all the help you have provided. Now, to get you going on Arduino, the first thing you need to do is you need the Arduino IDE. We go to Arduino.cc is the software, and then we download the Arduino IDE. And today, the version I'm using, the latest as of today, the version number is 1.8.3. So download and install the IDE. This can be on, this work on any operating system. That's one of the good, nice things about Arduino. But we are using Windows in this example right here, and you're going to need Windows like this setup here to use the DFU tool from ST. They probably have a Linux version, but you're going to need to figure that on your own if you're not using Windows. So install the IDE, and once the IDE is installed, you need to add the STM32 board support to the IDE. And ST Microelectronics is already work on that, and I'm guessing that's based on Roger's original work or not, I'm not sure. But you need to go to the STM32 Arduino GitHub. Now if you go on the wiki of that GitHub and you find the boards manager page on the wiki, it will point out the link, the proper link you need to add in the Arduino IDE to install the support package. So this is a nice feature in the Arduino IDE. The Arduino IDE, you can give it special, it's a JSON file, and you give it that file, and through that file the IDE will know what to install and what to add, what it needs to add support for another board. So copy the link from their website. It's going to be like STM32 Arduino board manager file / raw master, whatever it is, package STM index JSON. So copy that link, and then go back to the Arduino IDE, go File, Preferences, and under Preferences near the bottom you'll see Additional Boards Manager URL. You just need to paste that link in that area. This is just a link for now, it's not doing anything. So add the link, click OK. And the next step would be to actually go to the board manager in the IDE. And that is under Tools, Board Manager. Boards Manager. In this window, you have all the different options that you can install to the Arduino IDE. One of the options is going to be, because of that JSON file, like that link we just added recently, now you have an option, STM32 cores by ST Microelectronics. That's the one you need. And then you click on that, and then you have like a little install button. I'm using the 2017.8.4 version I'm using today. So go ahead and install. This is going to take some time. That downloads and install all the needed files on the Arduino IDE. After the installation is done, you will have now new options under boards. So you go under Tools and Boards, and now you will have under STM32 boards options, you will have Nucleo 144, Nucleo 64, etc., whatever else you have in there. So you need to click Nucleo 64. After you click Nucleo 64, go back to Tools, and there are board part numbers. That's right, that under board. So keep boards Nucleo 64, and right under that there is board part number. And then in board part number you need to select Nucleo F401RE. The F401 is the same processor that is on the BrainPad. So click that option. That's it. Now you can write code, Arduino code, and it runs right on the BrainPad. And let's start with a simple example, like a blink LED. So we go to File, Examples, Basics, Blink. And this will show you the blink LED, the default blink LED that ships with the Arduino. I would save this file. So File, Save As, and save it somewhere. So you can find it later because you need the output file. So save that file. Now you need to change, like the pin that's used over in this example is the LED, the default LED. What we want to do now is pick a proper pin. And I'm going to use the blue element on this RGB LED here on the light bulb. So this is RGB, red, green, and blue LED. I'm going to use the blue element on it, which is connected to pin PC6. Now, this is something that got me very confused, and it threw me off for a couple days. Using PC6 doesn't actually work. I'm not sure why ST chose to do that. I hope this will change in the future, so PC6 will work. For now, for PC6 to work, you have to convert pin name to digital pin. So the pin name is PC6. Digital pin is how Arduino named the pins, like D0, D1, D2, D3, etc. Anyway, for this to work, you just need to type pin name to digital pin PC6, and that would be the proper PC6 pin. So pin mode, we make pin the output, of course, and then in the loop, when we write high and write low, we also need to change that. So I'm just gonna copy paste this to first one and the second one. Good. Now we have a program that sets PC6 to an output, and then in the loop it sets it high, waits a second, and sets it low. Perfect. Now we go under Sketch, Export Compiled Binary. This will go through compiling the sketch, and when it's done compiling, instead of deploying it, it's like an Arduino, there's a bootloader and it deploys it. There's no Arduino bootloader on the ST boards. If you're using ST-Link, if you wire ST-Link here, then you can use the ST-Link to deploy the program right onto the BrainPad. Now, if I look into my output folder, I can click on Sketch, Show Sketch Folder, and it will show me the binary file that is generated by the software. Now, we need to load the binary file on any ST chip through DFU. You need to convert the binary to a DFU file. The first step, this is the same steps we always follow. You can go under, this is explained in our documentation under the STM32 bootloader. So if you want to see the instructions there, I'm going to do it really quick over here. So you go to, there's DFU file manager, and then from DFU file manager, you would generate a DFU file, select that binary file you have just generated, change the address to 0800000, that's 6 zeros, so 108 and then followed by 6 zeros, that's the flash address. You generate the DFU file. When you are done, you would open the DFU SE demo program. And those are tools, both tools come from ST Microelectronics. Click on Choose, select the DFU file you have generated. On your board, you need to put it in DFU mode, and you do that by holding the boot 0 button. Just hold it down, press and release reset. The board is in DFU mode. Go back to the tool. The tool now sees the device in DFU mode. Click on Upgrade. Yes. Successful reset. If we did this right, the LED will come on for a second, off for a second, and here you go, BrainPad running Arduino. Now the next step for this would be to make changes on the board setup files. So instead of having like this ST package that downloads everything ST, would be nice if there is a BrainPad or Fez package that you download, and it already includes everything, including the proper pin naming, so you don't have to do that conversion, and even perhaps even add the same BrainPad class that we have on C#. We port that to C++ on Arduino. So you would have BrainPad.lightbulb.turnBlue, for example, to turn the LED on without knowing what the actual processor pin name is. I hope you enjoyed this, and we'll see you next week.